Hi, this is a quick intro to the Junction box designed by Greg Brunel. You can see the box here itself, and along with the Junction box comes several extra leads that you may want to use. All of these have the pin connectors on one end and either the mini banana plugs or the BNC connectors on the other end. The Junction box also has an internal power supply, a 9-volt power supply, and so that if I just have it hooked up to no power source at all except the internal one, you can see that I have readings on 2 panel meters. What I can do though with the Junction box is, let's turn this off a second, is I have 2 other power supplies. I have an extra 9-volt battery on the back, and that would be simply plugged into the power terminal here. You can see when it's plugged in, 3 lights show up. There's a green light, a red light, and a yellow light. The green light indicates that we do have power to the circuit board. The red light indicates we have 5-volt supply available, and the yellow light indicates we have a 3.3 volt supply available. The best way to operate this though when you're not out in the field is to use the external power supply wall wart that's plugged into the wall over here, and the connection goes into the back, and you just leave the battery plug alone. So right now I have it hooked up to external power. The first thing I'd like to do is, let me clear these out of the way and zoom in a little bit, is I'd like to demonstrate the use of this Junction box with one of the sensors. So you've already used the photocell, and we're going to follow the same wiring convention that we had set up before. And if you take a look on the bottom left of the box, you'll see that the sensor inputs are labeled. The top one says ground, then 5 volts, then there are 3 signal connectors, and then 3.3 volts. So the 5 volts would be used for all of our sensors except the accelerometer, and we're going to follow the same convention as before. These are pin connectors. There's a pair of pins in each row, and they're hooked up together. So what I'm going to do is I'm going to hook up this photocell here, and I'm going to connect the ground wire first to the ground pin. The second pin, it needs 5-volt power supply, so I'll connect the red wire to the 5-volt power supply. And then the third one is the sensor output. Now I could connect it to any one of those 3 signal pins, but my convention is to use the first one available on the top there. Now I can turn the panel meter back on, and you see I have a reading here already. I have 0.62, 0.64 volts, and 0.7. And that's just the photocell looking at the lights up here in the lab, and you can see I can increase the voltage of the photocell by exposing it to a higher light intensity, or I could cover up the photocell with my hand and see that it drops down to 0. So now let's say what I would like to do is to take this signal from the photocell and amplify it. Well, I can use our standard op-amp box from before. We have it powered up. I've arranged the op-amp to be a non-inverting op-amp with a gain of approximately 2. So what I would have to do is on the input side for this configuration, I'd go into the plus-in terminal, and I'd take the BNC from that and go into channel that has the photocell on it. So this signal is live. It's the same as a photocell signal, and it's going to the input of the op-amp box. Then I have to connect to the output of the op-amp box, and I'll bring that BNC and connect it to our second channel. And you can see as I connect it to the second channel, we start to get a signal. It'll take a second to settle down here with the photocell, but we have a gain here of approximately 2. And you can see it's almost exactly 2 right now with the photocell showing. So that's basically all you'd have to do in terms of connecting an op-amp with whatever type of configuration you'd like. The final thing to take a note of is we have these output channels here. So I could take this and connect with a BNC connector, for example, to a digital oscilloscope to channel A. I could connect this to channel B of the digital oscilloscope, and I could figure out exactly what the gain of the op-amp is by looking at the ratio of the 2 signals. Also provided on the side of the junction box are output ports that go to the LabQuest. So basically you can take the LabQuest cable that's configured for this, plug it in, go to the other end to channel 1 of the LabQuest. You could put that in channel 2 of the LabQuest and basically record data as a function of time if you were interested. So you have the capability here with the junction box and the multiple connectors and the op-amp and the sensors and the sensor input and the LabQuest to run your complete experiment in which you would sense up to 2 variables, gain them appropriately, filter them appropriately, take their outputs, display them on a panel meter, and also run them to the LabQuest for data storage. So given that information, you're armed with a lot of ability, and good luck on your experiments.